Hey everyone, so this is the second half of the paper 2 prep sheet. Go for this first one then, all right, percentage calculations, just by knowing the basics here. All right, so question 1, the value of a car depreciates, which means it goes down by 7% each year. Given that the car was bought in September 2017 for $19,400, find its expected value in September 2025. Okay, so this car was $19,400. It's going down by 7% per annum per year. And then for how many years would it be? Well, from 2017 to 2025, that is for 8 years. Step 1, find your multiplier, okay? It's going down by 7%, remember, so you do 100%, take off 7%, that's 93%. Divide by 100 to make your decimal multiplier, that's 0.93. But this does all the work for you, okay? Then you can just take the 19,400, you multiply it by the multiplier. There you go, so see, take the original amount, times by the multiplier. And don't forget though, when it's repeated change, make sure you raise the multiplier to the power of the number of years. So this would be times 0.93 to the power of 8. Don't forget that power there, okay? Put in the calculator. So 19,400 times 0.93 to the power of 8 gives me a value of 10,855.89 to 2dp. Okay, job done. That's part A taken care of. Part B, classic cars tend to go up in value. Given that such a car was valued at 1.1 million in 2010 and is now worth 1.85 million, find the percentage change. Right, now everyone forgets the formula for percentage change. You can revise it. Percentage change, I'll put the formula here, okay? Percentage change is the change in the values divided by the original, multiplied by 100 to make a percentage. Everyone forgets this formula. Don't be one of those people. Okay, so to work out the change, first of all, the change in value, remember, okay, it was worth 1.1 million, now it's worth 1.85 million. So I'll just subtract those two. Remember, 1.85 million looks like this, and 1.1 million looks like this, all right? And if you subtract those two, then you get the change is actually 750,000 or 750 000. So that's the change. And the original value obviously is the starting value, which is 1.1 million. Which is, as a, remember, we'll take it, we won't put it as a figure, as a in words, we'll put it as a figure. Okay, so I've got everything I need now. Put them in the formula. All right, so the change is 750,000. But don't put the commas in the calculator, okay? The original is 1.1 million. Use your fraction button now, okay? 750, 123 over 1112123 times by 100. You actually get this quite a substantial change. It is 68.18% to 2dp. So remember that formula. All right, remember the formula, and you can't really go wrong. So I'll put that in green, make it stand out. All right, question 11 done. Okay, question 12 then on quadratic graphs. Very easy with a calculator, okay? Here's the function. Remember, this just means that y is x squared minus 2 times x minus 3, okay? I've only got 2 blanks to fill in. The first blank, look, okay, is when x equals minus 1. Okay, so if x equals minus 1, put it in. You do minus 1 squared, brackets are essential here. Take away 2 times minus 1, see, plus 3. See, x squared, take away 2 times x plus 3. Okay, so if you work this out, you should get 5 for the end. So for this is 5 here, okay, and a bit more as well. Oh, sorry, typing error, my bad. This is 1, add 2, add 3. This should give you 6 here, I believe. This looks wrong. Oh, sorry, my fault. It's minus 3. Read the question, sir. That is sloppy. Okay, so 1 plus 2 minus 3. Work it out. You get 0. Okay, which is promising because I can see another 0 here. All right. That was the first one, and now we got x equals 5. I'll do this one properly now. Okay. All right. You're doing x squared take away 2 times x minus 3. Okay, I'll put that in green. And if you work this out, then I think you're going to get 12, but I'll just double check. I'm paranoid here. After that first mistake, you're going to get 12. Perfect, okay. That's the table made. Part B then is here, look, all right. Want to plot the graph. This will go wrong for me because it's hard to do on my computer. Have a look, just plot pairs of points. First point is negative 2, 5, which is here. Negative 1, 0 is here. 0, minus 3. I think on this scale here, every small square is 0.5, so minus 3 would be here. 1 minus 4 would be here. 2 minus 3 would be back here. 3, 0 is here. 4, 5 is here. And 5, 12 would be here, I believe. Okay, remember then these quadratics always give us a U shape. So this would be, I won't be able to do this very well. In fact, this is going to be awful. You should be able to draw it in the exam, okay? And when you're on paper, oh, not bad. A smooth U shape. Oh, not bad, not bad, not bad. Remember, always write the function name down as well. X squared minus 2x minus 3. And that's the graph done. Draw the line y equals 3 on the same graph paper. Remember the line y equals 3. It goes through 3 on the y-axis, which is here. And it has to be a horizontal line. It can't be vertical because the vertical line's already there. Okay, so you just draw a nice straight line now. Okay, a horizontal line through 3 on the y-axis. Okay, so I will try with this here, make it nice and a nice straight line there. I'll make it a bit thicker to make it stand out. Hopefully this is all working nicely. There you go. I'll make it 3 point. There you go. All right, and that is the line y equals 3. That's one mark in the bank already. This is y equals 3. It's a horizontal line, not a vertical line. Okay. And then part D, write down the x coordinates of the point where this curve cuts the line. Remember, intersect just means where it cuts the line. So I can see it cuts in 2 places, here and here. And if you want the x coordinates, remember, just read down. Okay, I think this here, my first value, is about minus 1.7. And my other one is about here. So I think that's about 3.6, 2 values there, okay? Again, very easy. As long as you revise, know the U shape, you can't really go wrong. Okay, question 13 then. Just about knowing your square roots, your squares, your multiples, and your factors, okay? So Sam thinks of a number and writes it down. Good for Sam. The number is between 30 and 64 inclusive, okay? That means it goes from 30 to 64. And it can include both of these. So the number's in here somewhere, okay? The square root of the number is bigger than 6, but less than 7. Now, really, see the square number here, right? Should be thinking, shouldn't we, right? About the square numbers that live in this range. Remember now, all right, we should know that the square of, see, but root 36 is 6, okay? So this number is bigger than 6 for a start. And I know that then that root 49 is 7, okay? So this means this number, because it's less than 7 but bigger than 6, it means the number must now lie in the range 36 to 49. See, I've already narrowed it down. This range is gone now. I've narrowed it down. It's between these two numbers, this one and this one. The highest common factor of 16, and the number is 8. Okay, remember, so a factor is a number that goes into another number. So if we think now about 16, all right, and this number here, so the highest common factor of 16 and the number is 8. So it might be easy now to write, see these narrowed down numbers, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. You know, that was a long process, all right? So they've got a common factor of 8. So I'm going to check now, okay, for any, if this number, that means this number has to have an 8 in it. It has to be in the 8 times table. That's not in the 8 times table, okay? Nor is that, nor is that, nor is that. This one is, so I'll come back to it. This one is not in the 8s, 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 not in the 8s. This one is here. Okay, so there's only these two now, okay, left over. It's either 40 or 48. And the last thing, 3/4 of the number is a multiple of 5. Well, if we do 3/4 of 40, for example, remember on the calculator you can cheat, can't you? Just do 3/4 times 40. This gives you 30. And is 30 a multiple of 5? Yes, because 30 is in the 5 times table. So I think it's 40, but let's just check 48 as well. Hopefully this will be wrong. 3/4 of 48, I think is 36. It is 36. And this is not in the 5 times table. So it is 40. Then writing is 40. Okay? It's just like a logical deduction here, okay? Right? Go through each bullet point, narrow the numbers down, and eventually be left with a number. All right? And if you have to draw pictures like this, if you have to draw a picture like this, it's not childish, it works. Next question then, trial and improvement. And with this sort of thing, always make a table. Try values of x. Try the equation, and don't forget your comment column. Okay. Here we go. It says it's between 4 and 5, so I'll have to check 4 first and then 5. If you put 4 in, okay, remember, you're doing 4 cubed, take away 2 times 4, which I believe is 56. And that's too small because my target is 70. Okay. If you do 5 cubed, take away 2 times 5, you get, I believe, 115. All right. And that is definitely too big, as it should be. Now try 4.5, okay? So I'm not going to show my workings out now for this one. I'm going to put it in the calculator. I'll do 4.5 cubed, take away 2 times 4.5, and I got 82.125. That is still too big, okay? So now I know the answer is trapped between 4 and 4.5, so I might try 4.3, okay? So 4.3 cubed, take away 2 times 4.3, gives me 70.907. Oh, and that's slightly too big. All right, slightly too big. But that's good news because now it means I've tracked the answer between 4 and 4.3. See, between these two, because that's too small, that's too big. So I better try 4.2 next, didn't I? So 4.2 cubed, take away 2 times 4.2, gives me 65.688, and that's too small. That's good news, right? Because now I've trapped it between these two. Remember to check, you have to go in the middle, 4.25. So 4.25 cubed, take away 2 times 4.25, give me 68.26, yada, yada, yada. I don't care about the rest. All I know is that's too small, which means that I have trapped the answer now between 4.3 and 4.25? So just draw a picture. Remember, this is 4.30. So my answer, which is x, okay, lives in this range here somewhere, all right? And remember, it's going to be correct to 1 dp. So it's bigger than 4.25, but less than 4.3. Remember though, if it's bigger than 4.25 to 1 dp, you would have to round up to 4.3 to 1 dp, okay? And we're done. So put your numbers in, draw your picture at the end, make the smart choice, and you can't go wrong. Okay, question 16. Remember, there was no question 15. We've omitted question 15, okay? So this one, a rectangle has a width of 6 and an area of 27. Right, okay. So first thing I'll do is draw a picture. I need a picture. So it's got a width of 6 and an area of 27 cm squares. Find the length of its diagonal. Okay, remember, a diagonal of a shape, remember, is the line that goes from corner to corner. I'll do that in green, is it? I will a diagonal. Okay, so you'll probably be seeing, right, why this is Pythagoras, because there's a right angle triangle here, for example, and this is 6. All right, so maybe I'll redraw the triangle. All right, perhaps I'll work on this one here, where this green bit is the diagonal, okay? Because this is a right angle, obviously, all right? And this is 6 centimeters here, because those two sides are the same. I want to find this here, maybe I'll call it x, but remember to use Pythagoras, you have to be able to know the other side as well. Can we work it out? Yes, we can, because we should know, remember, that the area of a rectangle, remember, is length times width. So my thought process is 6 times something is 27. Length times width is 27. And obviously to find the question mark, then just do 27 divided by 6, which I believe is 4.5. This is a bad picture here, okay? It's a bad sketch, but it doesn't matter. This here is 4.5 centimeters. So I can legitimately get rid of that and replace it with 4.5. We're now Pythagoras. Go the old, A, B, longest side C, A squared add B squared equals C squared. A squared is 4.5 squared, which I think is 20.25. I will check in a minute, all right? B squared 6 squared, which I believe is, that is 36, no doubt. Let me just double check my 20.25, 4.5 squared. It is. Add those together now, okay, and you get 56.25. And don't forget to finish off, take the root. And let's go 2 dp, is it? Oof, lovely answer. Thank you, Mr. Meadows, for the lovely question. I should have spotted that, sorry, yeah. 7.5. Bang on. All right, centimeters. Thanks for that one, sir. That made me smile. Work, man. Done. Okay. Think about the areas. And Pythagoras, you know, it's a grade C topic, is super, super easy. A squared add B squared equals C squared. 17 then, probability trees. Very easy indeed. All right. I'll leave you to read all this by here. Okay. So pause it and read it all over. I'm going to go on with the question. Complete the tree diagram shown below. Right, and actually this is super easy, right, because there's only one missing branch here. And we know, don't we, all right, that at every stage of the tree, all right, each complete branch must equal 1. So if you just do 0.45 plus 0.25, I believe you get 0.7. Take it off big 1, and you get 0.3. That's easy. They have to make 1. That's too easy, all right? So what are the chances the player will select a black ball? Right, well, let's think now about how many branches work for the player selecting a black ball. Okay, well, definitely this one, right? Box A and a black ball. Next one, no, because that's a white ball. But box B and black, that counts as a black ball, doesn't it? Okay, and also box C and black as well. Okay, so remember, how do you get the answers at the end of each branch? Remember, you multiply. So this first branch, you do 0.45 times 0.7. So 0.45 times 0.7 gives me 0.315. That's that one. Right, let me put a separator here to make it a bit clearer. This one here, you do 0.25 times 0.4, which is 0.1. And this one you're doing 0.3 times 0.8, which is 0.24. Obviously, if you want to work at the rest of them, you can, but you only need these three branches here, okay? Remember, because it's these three chances all together, then you want to add them all together, you know, all right? Let's add these up together. Okay, so 0.35, well, 3.5 plus 0.1 plus 0.24 gives me 0.655. Remember, easy peasy, fill the tree in, pick the branches you want. Remember, to get the answer at the end, you multiply to get the end of a branch, then you add the branches you want together at the end. Could not be easier, okay? Last one then, trigonometry, very easy. Remember the old SOHCAHTOA, all right? We've got to find the length x. We know it's trigonometry because we've only got one side in an angle. Label the sides, H, O, A. Write down SOHCAHTOA, like I always do. SOHCAHTOA. Okay, what do I know then? I know H, and I want to find O. Therefore, is sine, okay? So remember sine 35. Remember sine is the opposite of the hypotenuse over H. So that's x over 14.3, okay? See, that's O. That's H over H. Remember now, when the unknown's on top, remember the saying? Unknown on top, you times, okay? On top, sorry, let me write that properly. Okay, if the unknown's on top, times, as we all know by now. So x is going to be 14.3 multiplied by sine 35. Okay, put in the calculator, 14.3 times sine 35, and you get 8.20, or 8.2, I suppose, to 2 dp. Done. That was part A. Could not be easier. Part B, again, we know it's trig. We want to find an angle. Label the sides. Remember, that's H. This one here is opposite. That is the adjacent. Okay, so write down SOHCAHTOA. All right, grab the old blue pen. I know A, and I want to. I know, sorry, and I also know O. So it's 10. All right, definitely 10. So remember tan y, the angle's called y. So tan y, but tan is O over A. All right, so O is 14.6 and A is 8.7. See, O over A. Remember then to find an angle, take the inverse function. Okay, so this one you would do, remember push shift then tan to get the inverse tan. 14.6 over 8.7. So shift tan fraction 14.6 over 8.7. Close bracket up, and you get 59.21 degrees. 2 dp. Trig's easy, right? SOHCAHTOA. You can't go wrong. To find an angle, use the inverse on top times. No problem at all.